Let's solve this rational inequality. Now, as soon as I see that I have a rational inequality, or really any inequality, I know that it's going to be the type of problem where we plot some critical values on a number line and then do some test values to see where the solutions are. But how do we get those critical values to plot on the number line? Well, in the case of rational inequalities, we have two sources of critical values. One source will be any excluded values. So looking at the denominator here, I see that x cannot equal -1. If I set this equal to 0, I see x cannot equal -1. So that's going on the number line. I can find other critical values by solving the related equation x plus 6 over x plus 1 minus 2 is equal to 0. If I solve this equation, that will give me other critical values. Now, one way to solve this equation is to make all the denominators be the same. So under the 2, I can put an x plus 1 to match this. Same with the 0. Oh, wait. It's only valid for me to multiply the denominator by x plus 1 if I also multiply the numerator by x plus 1. And I'll do the same thing with the 0. X plus 1 denominator, x plus 1 numerator. Now, all of the denominators are the same. So once I have the denominators the same, I can cancel them out. Be careful of one thing. A common mistake is just distributing a 2 and forgetting the negative sign. So really focus and be careful whenever you see a subtraction. What I like to do is move this negative sign right up on the 2 by making this a plus and then putting the negative sign right on the 2. That way when I distribute, I won't forget the negative. Anyway, the denominators are the same, so I can cancel them out. And I can make a new equation out of the numerators. So I have x plus 6. Now here comes that distributive property I was talking about. -2 times x is -2x. -2 times 1 is -2. Now 0 times anything is just 0. So combining like terms, the x and the -2x make -x. The 6 and the -2 make +4. Alright, so I'm just going to get x by itself. So I'm going to subtract 4 from both sides. So that's going to give me -x is equal to -4. And then I will just divide both sides by -1. So I get x equals 4. So this is a critical value. So these are my two critical values, the excluded value and the solution to the related equation. So this is what will go on my number line. Okay, so here comes the number line. So I'll put -1 here and I'll put 4 here. Now, excluded values are always graphed as an open circle. So this -1 will be graphed as an open circle. Solutions to the related equation are sometimes open circles and sometimes closed circles. It depends. If I had less than or equal to 0, then I would use a closed circle. Alright, because we just solved an equation. So 4 is a value that makes the function equal to 0. So if we want values that are less than or equal to 0, I will include them by making them a closed circle. On the other hand, if we just have less than, then we do not want to include values that are actually equal to 0 because we only want less than. So we'll show that these are not included by making them open circles. So this does not have the or equal to, it's just less than. So we are not going to include the 4. Okay, so that's going to be an open circle as well this time. Alright, now it's time to do the test values in each zone. So here to the left of -1, I could use things like -2 or -3. Between -1 and 4, I can check values like 0 or 2 or 3. To the right of 4, I can use values like 5 or 6 or 7. So, let's evaluate the function at each one of these x values. So, here's my function, and I'm going to use my calculator to help me out. So, using the table feature, let's just type this in. So, x plus 6 over x plus 1 minus 2. Okay. Make sure your calculator is in Ask X mode. So the values I want to evaluate are -2, 0, and 5. So -2, 0, and 5. So I get -6, 4, and -1/6. So I got -6, 4, and -1/6. In each case, we want to know if the function is less than 0 or not. So is this less than 0? Well, yes, that's negative. Is this less than 0? No, that's positive. Is this less than 0? Yes, that is negative. So the yeses show us where the solutions are. So we have solutions to the left of -1. We have no solutions in between -1 and 4, but we have more solutions to the right of 4. So this is a graph of our solution set. But we want to write our answer in interval notation. So this first interval is from -infinity to -1. So -infinity to -1. Use round parenthesis again to show that this point is not included. Union, and the second interval goes from 4 to infinity. And again, use round parenthesis to show that the 4 is not included either. Open circle. Alright, so that is the solution set in interval notation. So looking down here for it, alright, okay, I think this is going to be it. -infinity to -1, alright, round parentheses, and 4 to infinity. So the answer is B. Okay, so the only difference between A and B is that A has a square bracket at the -1, and that's no good. So the answer is B.